Good afternoon to you all. I welcome you to this session of experimental methods in fluid mechanics. Today we will discuss about displacement and area measurement. This is another module of this course, but before I start discussing about this, I will take 5 to 10 minutes to discuss about the impedance matching that we could not cover in my last lecture. So probably if you can recall that we have discussed that impedance matching. To know that what is that and why we should consider this, at least we should know that this impedance matching it is very important, because at least we should know effect of our measuring system on the physical variable that we are going to measure. That is very important. Again I am writing, though I wrote this statement in my last lecture, but even I am writing that we need to consider, rather we should know about this. We need to consider the effect of our measuring system. We will discuss this again, taking an example, the effect of our measuring system on the physical system we are going to measure. So effect of our measuring system, I can say, upon the physical system we want to measure. So this is very important. At least if we know this, then perhaps we can understand why you need to have impedance matching. Why you should have this impedance matching while you are measuring any variable using any equipment or any device or any instrument. So at least I can give you an example. Say if I place a cold thermometer in a bath, so placing the cold thermometer in a bath definitely will lower the bath temperature. So we need to know that if we place a cold thermometer in a bath, then definitely it will lower the bath temperature. Similarly, an accelerometer will increase the mass of the system, and that will change, I mean, how it will, another important thing is accelerometer will increase the mass of the system, changing how it will vibrate. So these two are example I have given you, that if we placing a cold thermometer in a bath will lowers the bath temperature. So that is what is very important, that if we would like to measure using a thermometer of the temperature of a liquid that is there in a bath. Now if the thermometer that we are going to take, rather we are going to consider for that particular measurement, if it is cold, then obviously it will lower the temperature. Similarly, now before I go to take this example, this impedance matching, this is normally encountered in electrical measurement system, but it is equally important for the mechanical measurement systems as well. So now keeping that in mind, at least we should know what is impedance matching, and perhaps I am trying to explain now with a small example and what is its effect, and if we do not know a priori about this, then what will be the consequence, that will be clear now. Now say many a times I will take an example of electrical measurement, system. Say when you want to make measurement of voltage, say we want to make measurement of voltage is very important, then we have to consider the impact of voltmeter on the device. So if we would like to really make measurement of voltage, then we need to have one voltmeter. Now we need to consider, rather we have to consider the impact of that voltmeter, on the device, because now our device will have an internal resistance. So basically what we would like to measure, drop in voltage across a device, and what we need to do, that device, rather our device will have an internal resistance. So say our device will have an internal resistance. Say Ri, and the voltmeter that we need, that is also having, because voltmeter we need to know the drop in voltage across that device. So now the voltmeter will have an input resistance. So the voltmeter, and rather we can say the meter have input resistance. So say this is R. So now then from this example perhaps I will try to explain why you need to have impedance and what will be its role. So it is clear that we would like to measure voltage across a device, the drop in voltage across a device. If we would like to measure that, then we need to rely on the voltmeter. So now whenever we are measuring that drop in voltage across the device, then we can assume that the internal resistance of that, or rather our device, is Ri, and the meter will have an input resistance R. So now what we do normally, we connect these resistances. So next I am writing, we connect these resistances, in series, right, across the voltage we want to measure. Say that voltage we want to measure, that is E, that is our objective is. And now say typically the voltage we measure is that across the resistance R, because, so I am writing typically we measure this voltage E we ignore the internal resistance. So, as if we are measuring voltage, say EM is that across R, is that across R, that is the resistance of the rather input resistance. Now, so this measurement EM, if I calculate in, since they are both the resistances are placed in series or connected in series, then definitely it will be R by Ri plus R into E. So, now that is, if I go back to my previous slide, that we want to measure E, we connect the resistances across series and we would like to measure voltage E, but typically we measured voltage EM and is that across R. So, now EM, it can be written is that equal to R into E divided by Ri plus R. Now, from this expression, what can I say? That our measurement EM will be always, because Ri, that is the internal resistance of the device, of our device, that will increase the resistance, that is Ri plus Ri over here. Now, so our measurement will be always less than the actual voltage. So, maybe we would like to measure voltage E, but we are getting EM, and from this we can see this EM, that is measured voltage will always be lesser than E. Now, how what we have seen, that the measured voltage will always be lesser than E. However, that as R becomes much larger than this Ri, so Ri is the internal resistance, as if we are measuring the voltage which is across R, that is the meter resistance. If Ri is much larger than Ri, then E will this EM. So, if R is much larger than Ri, then EM will approach, either EM approaches E closely, it becomes closer to E. Thus, that means from this discussion what we can conclude, that we would want to have the input resistance much smaller, much larger than the internal resistance of the device. That means we need to put a resistance while measuring this voltage, that input resistance should be much larger than the internal resistance of the device. Now, otherwise we cannot, we may not get the correct results. In that case, EM will certainly differ from the actual voltage that we should have. Now, see, this is all about the voltage measurement. As I said that normally impedance matching are encountered in electrical measurement system, but this aspect becomes equally important for mechanical measurement system as well. Now, if you would like to measure power or current, again require different impedance matching condition. So, this is the impedance matching condition, what? That the resistance, input resistance should be much larger than the resistance, internal resistance of the device. Otherwise, we should not have, we may not have the, rather we won't have the correct or accurate prediction. And for the similarly for the current and power measurement, different impedance matching conditions will be there, but the idea is same. And if you would like to really measure current, the situation regarding measurement of current is different, because we would want zero input impedance to ensure the current was not attenuated, the measured current was not attenuated. So, what we have understood that depending upon the measurement I mean the variable we are going to measure and whether that I mean knowing that the equipment which you are using to measure whether its effects on the physical system, we need to know that what are the things, rather what are the precautions we should consider while measuring. So with this next I will go to discuss about the next topic, that is the that is the next module, that is very important, that displacement and area measurement. So initially I am trying to discuss a few things which are very important to know, the measurement techniques which are largely related to flow measurements, flow variable measurements. So these are the basically recapitulations of several issues which are directly related to the measurement techniques. So now we will discuss about displacement and area measurement. See, in this module we will try to examine the enhancement area measurement, enhancement distance measurement. Displacement measurement, this is the broad term, largely we will be focusing on the distance measurement. So through this module we will try to examine the enhancement of distance measurement and then area measurement using pneumatic displacement gauge and the gauge blocks. So largely we will try to what we will do, we will examine the enhancement distance measurement, rather I can say okay fine, enhancement distance measurement distance measurement using the pneumatic pneumatic displacement gauge, and of course area measurement using several other techniques we will discuss subsequently, area measurements. So again I am telling that accurate measurements, be it distance, be it area or displacement. So displacement or area, that is basically dimensional measurement. So accurate measurements are very important for both industrial and experimental applications. So we have seen that many a time we use many types of different types of scales, tapes, calipers, micrometers for measurement of displacement, small distance, and then also vernier gauge. But it is very important to know that the accuracy, precision of those instruments are very important, because and particularly for the small measurement. So if you would like to measure very small distance, then how can we measure, and if you would like to measure, then what are the devices available, what are the equipments available, that is what we will discuss today. Now say as I said that distance measurement or area measurement, their accurate measurement of distance is very important, as I said that they are important for both in industrial and experimental applications. So, accurate distance measurement, rather measuring instruments, we know that micrometers, then other things, other devices, that is what I said that calipers are there, but probably using micrometer we can have accurate measurement, but that micrometer when you are using for accurate measurement, that must be calibrated periodically, as there will be a chance of having error in the measured data. So, accurate distance measuring instruments such as micrometer for example should be calibrated periodically, because there will be a fixed error that changes with use. So, if we do not calibrate them periodically, then again we may come up with our measured data which is not correct. So, I am writing that when we talk about distance measurement, if we know that accurate distance measurement measuring instruments say for example micrometers. So, accurate distance measuring instruments, for example micrometers, there are many. So, those instruments should be calibrated periodically. So, rather I can write must be calibrated periodically. Because why you need to have this periodic calibration? Because there will be fixed error that changes with use, because we will be using this repeatedly continuously. So, this error arises due to what? So, if we keep on using a micrometer for measuring distance, so one important thing is that is what I am discussing, that when we talk about, so distance measurement is very important both in industry and experimental application. Accurate distance measuring device, there are many instruments, there are many devices, like for example micrometer is one of them, but those devices must be calibrated periodically. Why? Because there will be fixed error that changes with use, because we will be using continuously. Now, the sources of error are because we will be using all our mechanical instrument, mechanical device, so wear and deformation. So, the sources of error are mechanical wear and deformation. So, considering this, we need to calibrate them periodically. Now, with this we will now see that if you really need to have a very small measurement, in addition to the micrometers, there is another device which is known as pneumatic displacement gauge. So, today I will discuss about that knowing that we need to calibrate those accurate measuring devices periodically, because of the fact that they are used continuously, and because of that mechanical wear and deformation leads to fixed error in the measurement process or measurement system. Now, in addition to that, that accurate measuring device micrometer, another device that is what we will discuss, that is called the pneumatic displacement gauge. So, pneumatic displacement gauge. pneumatic displacement gauge. This gauge is essentially gives us the rather used for very small measurement. So, this is used for a very small distance. And it relies on, again, because since this course is on experimental methods in fluid mechanics, so basically this gauge use air as a working fluid. This gauge used air as a working fluid, and then we will see now from the schematic of this gauge that the principle of measuring small distance or small distances using this device, I mean what is the basic principle. So, basically pneumatic displacement gauge, the word pneumatic, that basically it tells that it is having air as the working fluid, and this fluid is taken through a special type of arrangement system, that is what we will discuss. But while we are using air to measure small distances using pneumatic displacement gauge, we treat air as an incompressible fluid. So, here we treat air, this is an assumption, but the validity of the assumptions can be found in many textbooks and Holman or even classical fluid mechanics textbook. So, air is taken here as an incompressible fluid. So, this is one important assumption that we need to consider for measuring small distance using this device or gauge. So, this is assumption. As I said that the validity of the assumptions can be found in textbook like Holman, experimental methods, and many other textbooks which are focusing on several experimental methods. And considering that assumption, now we will slowly move to see that what is the working principle of this device and by how it measures small distance. So, first of all I will try to draw a schematic. So, I am now trying to draw a schematic. Again I am writing pneumatic displacement gauge. So, I am now and say this diameter is d1 and this diameter is d2 and so we have a cylindrical shaped exit, just nozzle. So, this is basically nozzle shape portion, and we are having over here an object. So, this is object and or workpiece, we can say this is also workpiece and say this distance that we would like to measure, that is say x, right, and say we are having flow of air flow, or I can write air flow. Now we need to have gauge pressure, I mean pressure, say this is one pressure gauge P2 and this is one P1. So, this is very important that we will measure this and let us say ambient pressure is the ambient pressure is equal to PA. Now, so as I said that this can be used to measure small distance x. So, basically this distance we want to measure. So, that is the distance we want to measure. Now, it is composed of a circular tube. So, I am writing it is composed of circular tube containing an orifice plate containing orifice plate flow meter followed by a nozzle on a common axis. So, this is the structural shape. So, that is what I have written over here, that the axis is common. So, basically this is the axis. So, it is composed of a circular tube containing an orifice plate, say this is the orifice, this is orifice plate and orifice plate flow meter and followed by a nozzle on the common axis. Now, see the gauge will be placed normal to the workpiece. So, the workpiece is extreme right hand, that is extreme right side, that is what we have drawn, object or workpiece, and gauge is placed normal to the workpiece such that the nozzle is at a distance x from the workpiece, and this distance, that is what we would like to measure, x. So, when we are going to measure x, again with this gauge there are two pressure gauge, there are two different pressure gauges are connected to this displacement gauge P1 and P2. One is placed at the upstream of the orifice and another is the downstream of the orifice. So, placing these two pressure gauges and now having flow of air through this orifice meter, then nozzle, we can calculate, rather we can measure the distance which is very small. Now, we will discuss, because again when we will be discussing to know the working principle of this displacement gauge, we again need to know the basic fluid mechanics, whatever we have learned. So, essentially what we have to do, we have to measure flow rate through the orifice as well as flow rate through the nozzle, and we have considered one assumption is that air is considered to be an incompressible fluid. So, I mean the flow rate we can equate through the orifice as well as through the nozzle. Now, from there with some mathematical manipulation, we will see that how we can arrange those things, and we will come up with a equation that will give us the relation between x and the measured pressure through the gauges P2 and P1. So, just I am telling you what we will do. The flow rate through the nozzle will be related to the displacement x, and now the flow rate is again linked with the measured value of pressure using the gauges placed in the pneumatic gauge. So, indirectly we can relate what will be the measured distance x through the measured value of pressure using the gauges, and from there we can say that what will be the. So, by knowing the by measuring the pressure we can say that what will be the displacement. So, again I am telling we need to know that flow rate through the orifice meter and flow rate through the nozzle, and after calculating the flow rate through the orifice meter and flow rate through the nozzle, we need to do a few algebraic steps, and then we will try to see that how we can relate x in terms of the measured value of pressure using the gauges. We will discuss this issue in detail again, then I mean how we can relate this x in terms of measured value of pressure, and that exercise we will do in the next class. Thank you very much.